Hi, a very good day to everyone. Myself Swathi.P from Sri Venkateshwara College of Engineering. So for today's video, we have system software under that lex and yak functions. So first, what is lex function? Okay, so lex is officially known as a lexical analyzer, where we refer to tool as lexical compiler and its input specification is the lex language. So lex source program, whatever the program we have typed, it is saved as the lex.l, and the lex compiler compiles the source program, and lex.yy.c is the command for checking the errors, and C compiler, okay, whenever there is no errors, it goes to the next stage, that is a.out, which is used to check the output of the given source program. Okay, the input stream, whatever input is given, that is read by the a.out command, and it gives the output in the form of sequence of tokens. So this is basically the part of the lex, where it is a lexical analyzer, where it basically involves the token survey scanning is performed. So next, let us see what is yak. Yak is officially known as parser, and the parser output form is the parsing tree. So yak stands for yet another compiler. This is because this kind of analysis of text files is normally associated with writing compilers. So here in this diagram, we can see the yak specification, yak compiler, which gives y.tab.c for it is the command. When y.tab.c is run, it goes to the C compiler, then a.out is the output command, which is used to view the output. Input is given, and the a.out is type, which gives the output of the given source program. So this is basically what it is, the functions or whatever the operation that is performed in the yak. So let us see a few of the yak lex functions. So YYL val is a global variable that is used to pass schematic values associated with the token from lexer to the parser. So it is basically a schematic values associated with the token, which is used to pass from lexer to parser. YY text is a string pointed to a list of null terminated characters that holds the text matches to current text. If 12 is an input, then YY text for number is 12. So YY text is nothing but it is a full null terminated character that holds the text match to the current token. So whatever token, like for example 12 is an input, then YY text for number is 12. Whatever the that holds the text match to the current, whatever text is there that is matching to the current token, that is called as YY text. Next one is the YY lex, is the entry point for lex program. It reads the input stream and generates a token in the form that is the output. It is defined in the lex.yy.c file, but it needs to be manually called by the user. So YY lex is basically pointer for the lex. It reads the input stream. To manually read it, it should be called by the user. Next one is the YY wrap. Is called it is called by YY lex when the input is exhausted. If 0 is seen, YY lex will keep reading from the pointer YY in. If 1 is returned, then the scanning process is terminated. It is mandatory to define in the lex file, that is 0 means true and 1 is false. Basically, it is saying that 0 is there means then YY lex will keep on reading the pointer YY in. If 1 is returned, then the scanning process is terminated. It is mandatory to define the lex file. So the next one is the YY parser, which is the parser. It calls YY lex for lexical analysis. It returns 0 is the input passes according to the rules else 0. So lex functions here, YY val is a global variable that is used to pass the schematic values from lexer that is associated with the token from lexer to parser. YY text is it matches whatever the things are there. That is, it generates a token is defined in lex.yy.c. So the next, let us see the next. That is the yak functions. Each translation rule input to yak has a string specification that resembles a production of a grammar. It has a non-terminal on the left-hand side and a few alternates on the right-hand side. For simplicity, we will refer to a string specification as production. So Yak generates a LA/LR parser for a language L from production, which is a bottom-up parser. The parser would operate as the following. For shift action, it would invoke the scanner to obtain the next token and continue the pass by using the token. While performing a reduced action in accordance with production, it would perform semantic action associated with that production. So it is the Yak basically is a translation rule of Yak is the string specification. That is the non-terminal from the left-hand side and few alternatives on the right hand side. For simplicity, we are the output of the Yak is we build a particular what is that we say parse tree is the output for the Yak functions. That is the parser. So this is the okay. Here we can see this is the structure of a Yak and this is the structure of a Lex program. Okay, in the diagram you can see that Yak basically consists of three structure. That structure is classified into three types. There is the definition, the rule section, and the auxiliary routines or the subroutines. So the definition is the definition part includes information about the tokens used in the syntax definition. For example, the percentage token number or percentage token ID, which are the delimiters. The percentage is nothing but the delimiters. Yak also recognizes single character as tokens. Therefore, assigned token numbers should no overlap ASCII codes. So the definition part can include C code external of the definition of the parser and variable declaration within the percentage, open the flower bracket and closing of the percentage symbol and flower bracket. So these are the delimiters within the first column or within the end. It can also include the specification of the starting symbol in the grammar, that is the percentage start non-terminal input file. So next one is the rules section, that is the input file. The rule part contains grammar definitions in a modified BNF form. BNF form is nothing it is nothing but Barker's norm form, which contains the syntactic meta languages. The syntactic meta languages are grammar, that is the context-free grammar, regular expression that is used in the programming. So actions in C code can be embedded inside. So the next one is the auxiliary routines or the C routine. This basically considers a C program main function. So if the auxiliary routine part is only C code, it includes function definitions for every function needed in the rules part. It can also contain the main function definitions in if the parser is going to run as a program. The main function must call the function parse. Okay, if the YY is not defined in the auxiliary routine section, then it should be included with hash include lex.yy.c. So here the structure of Lex program is same as structure of Yak, but it has only two sections. That is the definitions and the rule section. The C, that is the subroutine section, is only present in the Yak. This is the only difference between the Yak and the Lex program. So let us see a simple program on Lex and Yak program. So here we have the declaration section. As we had seen in the previous slides, that this is the delimiter. Hash include is the header file, and int yy error function prototype. These are all function prototype, and int num is a global variable. We are declaring it globally, so the number can be. So this is the numbers 0 to 9 plus. That is, it can be plus or 0 to 9. It is the 0 to 9. Any numbers plus is one or more numbers should be printed. So this is the rules section. These are the delimiters. Numbers are written ETOI. It is used to convert the Lex to Yak program. It is the command. Then YY text, we had seen whatever the token text is given, the same is printed in the output field. Like example 12 is there, and the output is also 12. So E to Z and caps A to Z plus okay hello. Return 0, return YY error, YY text, auxiliary functions int wrap, return 1. Okay, now here it is the subroutine function, that is the main function int main. Okay, printf is the output function, that is what is your name. When we parse, once the scanning is done, we get the output. What is your age? Num is equals to y by x, and number greater than 18. How you doing? Call me when you're 18. Like if the age is less than 18, it will just return 0. If the age is if the age is more than 18, it will return 0. If it is less than 18, then it will just print like call me when you're 18. I don't understand error values. So this is the few of the commands to run the program. So to start a program, we have to give the vi space program dot l for lex and vi space program dot y for yak program. So once we have typed the source program, we have to give the command like lex. For lex, it is lex file dot l. That is vi program dot. Then for CC, it is used for C program compilation. So for looking the output, dot slash a dot out is the output command. So so whenever we run this given program, we get the output as what is your name, then what is your name. So the input, what is your name is the output. So we give the input as hello Rose. Whenever we press the enter, it asks for what is your age. So the input we have given here 12. So the age is less than 18. So the output function is given as call me when you're 18. If we give input as 19, then it will just going to return 0 because we have given the limit as a number greater than 18. Okay. So this is for today's video, that we have seen what is the lex and yak, and we have seen few of the lex and yak function, and at last we have seen the lex and yak program and how to run them and how to get the output and what are the YY lex, what is YY text. All this we have been seen in today's video. So thank you. Have a nice day.